Good morning, everyone. Good morning. Am I audible? Voice clear? Am I audible? Good morning, Ananya. Good morning, Harsha. Okay. Dosakai. Dosakai, I have heard it is a vegetable here. Am I right? Okay. Yeah, very good morning. Very good morning. Good morning to all. Avya, Harsha. This weekend up to, it will be informed, whatever we are discussing in class, it will be up to that portion only, including some portion of the introduction. That will be there. Okay, Tari Gonda, yes, good morning, beta. Nikita, good morning, good morning. I hope students you are working, you are going through the NCERT pages which I mentioned in the last lecture. Every lecture I mention the pages and the paragraphs so that after the class you can read these things and you remain in sync with the language of the NCERT. Okay, okay, yes, good morning, Anu. Getting it? So last class, which part we have discussed? In the last lecture, we have discussed the ionic bond and lattice enthalpy we have done. So what was the exact part where I left? We have done the examples or only factors we have discussed? Examples also completed or only factors? I think factors also completed and examples also done. Yes. I think I have given one example. I have said that I will ask in the next class. One student was there, she said formula I have written wrong that time. Yes, I remember. That example was this example was done. This example I have given at the end that yes, this example you have to compare their lattice enthalpy. Bolo. Yes, very good morning, informative. This question I think I have given at the end that identify out of these two which has more lattice enthalpy. This question at the end I have given as a homework I have given, I think. Okay. So Saiti, have you tried? Other students, have you tried? So what's the answer? How many considering first one? First one, suppose Mg3N2. And second one is Al2O3. How many considering first one or second one like this? Lattice energy, Al2O3. Monica is saying that one. Second one, okay. Talking Swarup is saying first. Rakesh Kumar, Al2O3 second. Acha, haan, it is greater, okay. Syam Chandu, okay, Al2O3. Josna is saying second, Al2O3. Maximum is giving, yes, Harish also saying Al2O3. Harshini also going with second, good. Vijay, Ananya, second greater than one, right? Right. Madhu Shadana, yes. Madhu is saying that one, okay, we'll discuss. Dharani 2, Anu, Saiti, Sunita, all 2, Surya, Kirtana 2, Tanmay 2. ठीक है, 2 greater than 1. Now, Ratnam already it is going in the classes, regular classes also same content and online also. So nothing is going to be repeated anywhere. Okay, now the reason for second is what? Reason for second is firstly charge factor. Cation is here +3. Here anion is -3. Here cation is +3. Here anion is -2. So here favorable factor C in terms of the charge on the cation. Here it is +3. Okay? And here size of the anion is -2 oxygen, -3 nitrogen, which has more size. which has more size, it is O with -2 or N minus 3, N minus 3, right? Similarly, Mg plus 2 and Mg plus 3, which has more ionic size, Mg plus 2. So overall, by the radius of the ion factor or size of the ion factor, lattice enthalpy inversely proportional to the ionic size or radius of the ions involved. Hence, out of these two, Al2O3 has maximum lattice energy. So reason you will mention lattice energy inversely proportional to the size of the ions involved. Which one? Oxygen -2 smaller than N minus 3 and aluminium plus 3 is smaller than Mg plus 2. Okay, got it? Now, we will start with the next part, page number 112 in this book. If you have another book, you can check that one. Which part you will check? You will check in the dipole moment at the end, table 4.5. Above that, this portion is given, which is just as all the covalent bonds. This portion you can mark for today, that you will read after the class also. Which part it is? Fajan's rule. Got it? So you can mention in the notes or you can mark in NCERT first. This portion we are going to discuss now, which is under the category of polarization and Fajan's rule. Okay, now I am changing the background or going to the slide. So you will mention in the notes polarization and Fajan's rule. And basically we talk about covalent character. Covalent character in ionic compounds or covalent character in the ionic bond. Okay? So today we are starting the Fajan's rule, or the important terms like polarization, polarizability and polarizing power. So firstly understand the meanings, because ultimately questions are asked not on the theoretical points, it is asked on the example points. Clear? Then understanding of the basic terms is required to go through the examples. So firstly understand when we talk about the polarization, this is cation and this is anion. Suppose this is the example, you understand fast. When we say in ionic bond, what happens? That as per the Fajan's rule, no bond is 100% ionic in nature. There is some covalent character associated with it. Some covalent character is there as per the Fajan's rule, that 100% no bond is ionic. Then what happens? Cation will attract the electron density of anion. Cation will attract the electron density of anion towards itself. With time it will attract. So this attraction of the electron density of cation, or this attraction of the electron density of anion by the cation, or this shifting of the electron density of anion towards cation. Shifting means some distortion, we can say, distortion of the electron density of anion towards cation. This is known as polarization. It is known as what? Polarization, in which cation is attracting the electron density of anion and distorting the electron density of anion towards itself. This is termed as which process? It is termed as polarization. More is the polarization, more is the covalent character, or less will be the ionic character in the ionic bond or ionic compound. Getting it? So it is which process? When the cation attracts the anion, or it attracts the electron cloud of anion, then electron density partially tilt or distort towards cation. This is termed as polarization. More polarization, more covalent character, less will be the ionic character. ठीक है. Now you can write down also this part, that write down the first point. लिखे. Write down the point. That points I will say. What is the meaning of polarizing power after this point by point? So first you write down, no bond is 100% ionic. No bond is 100% ionic in nature. No bond is 100% ionic in nature. There is some covalent character. There is some covalent character associated with it. There is some covalent character associated with it. Second point. In ionic bond, cation attracts the cation attracts the electron density of cation attracts the electron density of anion. Cation attracts the electron density of anion and distortion of electron density. Distortion of electron density from anion towards cation takes place. From anion towards cation takes place. It is termed as polarization. It is termed as polarization. Written. अब देखो, okay. Yes, Sunita, we'll discuss polarizing power and polarizability after this point which is written. Then Rakesh, yes, it will be informed in the group. Then yes, okay, syllabus आ जाएगा. Sujata Devi. Then your number. You can talk to Prasad ji, na? PA Prasad is there. You can talk to Prasad ji. He will add in the group. ठीक है. Second point clear. Second point clear. What is polarization? Attraction of the electron density of the anion by the cation. This is termed as polarization. Then you mention higher the polarization in the second point itself. Mention there higher the polarization. Higher polarization means, or more will be the covalent character, or less which character? Ionic character. Higher polarization, more covalent character or less ionic character. Okay, Ganeshwar, you can message me now. I'll share your number with them. Okay? You can message me. I'll share your number to Prasad ji. I think he's admin there also. He can add. Or if I am admin, I can also add. But generally, I'm in classes, so I forgot all these things. Higher polarization means more covalent character or less ionic character in the ionic compound. Now, why covalent character increasing due to distortion? So you can understand very easily that when we talk about the covalent bonds, so covalent bonds are which one in which electrons are mutually shared by the both atoms. So what happens generally, electron density lies between the two atoms. Electron density lies between the two atoms, so that is why it is the covalent bond. Now here what happens? In ionic bond, cation is attracting the electron density of anion in such a way the electron density is coming slightly between the two nucleuses or two nuclei. So one electron density is coming in between the two ions. Then which character is developing? It is covalent character is developing. That is why more is the polarization, more will be the covalent character in the ionic compound. Clear? Getting it? Meaning clear? When we go for NCERT, this information is also given. Okay, write down the next point. Niranjan, it's a first class, na? Morning classes, some internet issues were there. So already it is informed in the group. Okay, Ganeshwar, my number is this one. You can send me your message with your name. Then when I'll free, I'll send this to the concerned person. I will tell them this is my number. You can message Ganeshwar Sai, whichever is your name, or what is the procedure. I will tell them any group is there or not. ये यहाँ बच्चा एक है ये he is saying that गणेश्वर प्रसाद सर का नंबर उसने नंबर ऐड नहीं किया ग्रुप में he is saying that I told to principal sir but not he yet added not added तो आपका नंबर दे दूँ what's the number 8309 121 817 इसको दे दो तो ये नंबर है प्रसाद जी का व्हाट्सएप करने के लिए बोलो ऐड करना WhatsApp. Ganeshwar, you can send WhatsApp message on this number. ठीक है? Prasad ji will add your name in the respective group, online group. I will send the link. He will send you the link also. Anyone. ठीक है? Anyone. All the students who they are not added in the groups, they can send their message, WhatsApp message on this number. Prasad ji will add them. ठीक है? Next term is polarizing power. Now, polarizing power is what? Polarizing power is basically, it is the ability of cation to attract the electron density of anion. It is the ability of cation to attract the electron density of anion towards itself. More is the attraction, more it is the distortion of the electron cloud, more is the polarization. ठीक है. So here you can mention polarizing power is associated with which one? Cation. So mention here, it is the ability of cation. It is the ability of cation to attract. It is the ability of cation to attract electron density of anion towards itself. Electron density of anion towards itself. So finally, what we can say in short, polarization is directly proportional to the polarizing power. Polarization is directly proportional to the polarizing power. That means more attraction or more distortion of the electron density takes place, hence more polarization. More polarization means more covalent character and lesser will be the ionic character. ठीक है? So polarizing power is a term for cation. Next term is polarizability. What's the meaning of polarizability? Polarizability is for which one? It is for anion. So write down, it is the tendency. It is the tendency it is the tendency it is the tendency of anion to distort it is a tendency of anion to distort electron density towards cation. Electron density towards cation. It is the tendency of anion to distort its electron density towards cation. Towards cation, or you can also say, or it is the ability, or it is the ability of anion to get polarized. Ability of anion to get polarized by cation. Ability of anion to get polarized by cation. So finally, in short, what we can say from this point, polarization directly proportional to polarizability. And polarizability means what? Polarizability of anion, and polarization also directly proportional to polarizing power of cation. So more is the polarizing power of cation, more is the polarization, more covalent character. More is the polarizability of anion, more is the polarization, more will be the covalent character. ठीक है? Now, write down the factors that affect the polarization. First one is charge of cation. In charge of cation, charge whether it is cation or anion, condition remains same. More charge on the cation, more will be the polarization, more covalent character, or less will be ionic character. ठीक है, तो write down that one here directly. Charge on cation में polarization directly proportional to the charge of cation. So you can say directly proportional to the covalent character, inversely proportional to the, yes, ionic character. Getting it? Polarization directly proportional to the charges, maybe cation or anion. That means directly will be proportional to the covalent character, inversely proportional to the ionic character. ठीक. Now size of the cation में, in size of the cation, if you observe, in cation of small size, more charge density will be there. Smaller size cation has more charge density, hence it will attract the electron density of anion very strongly. Hence, smaller the size, more will be the polarization. Smaller the size of cation, more will be the polarization, more will be the covalent character, less will be the ionic character. So all that story precisely you can mention here. Polarization inversely proportional to the size of cation. Smaller the size of the cation, more polarization. Or you can say directly proportional to covalent character, inversely proportional to ionic character. ठीक. Next term is charge on the anion. Charge on anion same, just like cation. More charge on anion, more is polarization. So polarization directly proportional to the charge. Directly proportional to the covalent character, inversely proportional to the ionic character. More charge on anion, more easily it will distort towards cation. Hence, more covalent character and lesser will be the ionic character. Next point, charge on anion हो गया. Next is size of anion. Size of anion में, if anion is of bigger size, then what happens? The electrons distance from the nucleus will increase. Electron distance from the nucleus will increase, hence they are loosely bound to the nucleus. And if they are loosely bound to the nucleus, then these electron clouds or electron density will easily distort towards cation. It will easily distort towards cation. Hence, in this case, size of anion, polarization directly proportional to size of anion, which was exactly opposite with size of cation. So here, important, you can write down, this is the different. Polarization is directly proportional to the size of anion. If more is the size of anion, more is the covalent character, less will be the ionic character. Written 4 points. Fifth point is cation with pseudo inert gas configuration. Cation with pseudo inert gas configuration has more polarizing power, than cation with has more polarizing power than cation with inert gas configuration. Has more polarizing power than cation with inert gas configuration. with inert gas configuration. This you will understand with example. Okay. Written these 5 points. These 5 points completed. I hope you have written. Now we'll talk about the examples. Directly apply the factors in the examples. In brackets, I am writing which order you have to write, covalent character or ionic character. Okay, that I am mentioning in the brackets. Compare the order here among them. ठीक है. Now in first one, what is common? Cation is common. And what is different? Anion being different. So compare among the anion. And anion charges are also same. Difference is size of the anion. So quickly recall, polarization is directly proportional to the size of the anion. More is the size of anion, more will be the covalent character, or less will be the ionic character. Take. Now observe here, I minus and Cl minus. Question is about which character? Covalent. So I minus, more polarization is given by the anion, more will be the covalent character. So reason you can mention, which point you can mention? Point number 4. I think 4 point in the factor. Polarization directly proportional to the size of the anion. Then try similarly second one. In second one, what is common? Anion common now. What is different? Cation. Na plus, K plus, Rb plus. Charge of the cation also same, but what is different? Size of the cation. As size of the cation decreases, polarization increases, covalent character increases. So among these, Na plus smallest cation, Rb plus largest cation. So which is most covalent among them? Most covalent character. First one. And question is about which character? Ionic character. Very good. So answer is RbCl, maximum ionic character. Among them NaCl, least ionic character. ठीक है? It is 3, 2, 1 in decreasing order. Then try next two. in, okay, next three you can try. Write down next three, complete it, then I'll discuss together. These three, then next three. Yes, like in that I will do. Try third, fourth, and fifth. If it is completed, then tell me. Third, fourth, and fifth question in one go I will discuss. Completed third, fourth, and fifth. If you have completed, you can try other one, but firstly I'll focus on 3, 4, 5. I hope by this time you have completed it. Most of you have tried at your end. Okay, I'm writing the answer. Let's see how many of you getting the correct answer. Question is about covalent character. Next one about covalent character. Next one about covalent character. ठीक है चलो 3, 4, 5 completed. Check your answer. Very good, those who are responding. Very good. If you want to ask among these three, any doubts? Third, fourth, and fifth. Correct. Very good. Those who are getting all correct. Very, very good. ठीक है, Shyam, I will explain fifth one. In fifth, what's the differentiating factor? N nitride ion -3, N same here -3. Nitrogen anion being same. What is the difference? Cation. Here cation with charge +3, here with charge Mg +2. +3 cation +2. Differentiating factor directly you can mark charge factor. Polarization is directly proportional to the charge and more covalent character. Even by size of the cation you can get, but when charge is there, go by clearly charge factor. Sham, now clear? It is by the aluminium +3 comparison with +2 of magnesium. Polarization directly proportional to the charges. ठीक है, third one. In third one, which is common? In third one, who asked? Explain fourth. Third, someone asked? नहीं. Fourth asked. In fourth, differentiating factor is what? What is common? Anion same. Anion same, differentiating factor is cation. Li plus, Na plus, K plus. Size of the cation increases. Polarization decreases, because already written polarization is inversely proportional to the size of the cation. So among them, the most covalent character will be with Li plus. That is why that's the order. Clear now? Shankar Nayak, clear? Vijay, now clear question number 4. You will use the point polarization inversely proportional to which one? Size of the cation in example number 4. Completed? Example 2, Blessy. Array, already it was gone. 2 months back gone. Already reasoning I am giving. You have to write it fast, bhai. NaCl, KCl, anion same concept like fourth one. Anion common, cation being different. Polarization is inversely proportional to size of the cation. That means Na plus maximum polarization, most covalent character. Therefore, ionic character is asked, not covalent character. You have to see the question properly. Getting it? Let's see. Then another is any other. Third also discussed charge of the cation. That's it. Anion being same, and cations are different. +3 most polarization, most covalent character. Now try next 3. Try next 3, 6, 7, 8, or you can try next 4, then 10th example by last factor of the notes, pseudo inert gas and inert gas comparison. Complete 6, 7, 8, 9. Okay, answers are coming. 6 salts, 8 salt, very good. I hope you people are getting it and trying at your best first before asking. Make this habit, you will ask when you have tried it properly. And where you will try? From the factors written. Okay, I'm discussing next question number 6th. In 6th, it is anion being same. What is different? Cations are different with different size. Beryllium +2, Mg +2, calcium +2. Charge of the cation same, but size of the beryllium +2 smallest, because in periodic table you have done top to bottom size of the atom increases. So here smallest is beryllium +2. Polarization inversely proportional to size of the cation. Smallest cation, maximum polarization, maximum covalent character, and question is not covalent character, question is ionic character. So answer is reversed. Take then AlF3, AlCl3, AlBr3. What is common? Cation. What is different? Anion. In anion, fluorine is with charge -1, Cl -1, Br -1. So here you will use size of the anion. Polarization directly proportional to size of the anion, which is maximum Br minus. So it has maximum covalent character. Question is covalent character. Take 8th, cation being same, anion different. One is F minus, other is O -2. F minus and O -2. Charge factor also you can say directly that O -2 more charge is favoring more polarization, so more covalent character. Yes. Covalent character will be opposite. Sadiq, yes. Ionic character is inversely proportional in 6th case. Na? Ionic character already given. CaCl2 most ionic, covalent character will be reversed. Next one, 9th. In 9th, answer given by Suharshita, it is given, okay, very good, 2 greater than 1. Answer is 1 greater than 2. Covalent character, question already given. Question already given with covalent character. Na2 is only given for which purpose? Na2 means we are balancing the charge of the molecule. Cation is still Na plus. ठीक है? So up to 9th, any doubts you have? 9th, Vijay has a doubt. Vijay, think, firstly you think, what is common? Aluminium common or not? Take differentiating factor. Nitrogen with charge -3. Why? Aluminium +3 and -3. Same way here, aluminium common, oxygen -2. N -3 and O -2. Which is more charge? N -3. Hence, which has more polarization? N -3 more covalent character. Now clear, Vijay? Now next example from the pseudo gas configuration and pseudo inert gas and inert gas. NaCl. NaCl में cation is what? Na plus. Here Cu plus. Na plus configuration, valence shell configuration. Inert gas valence configuration is helium is normal, then 2s2, 2p6. This is valence shell. And how many electrons are there? 8 electrons in valence shell. That means which configuration? Exactly inert gas configuration. Take, but in copper plus 1, if you write it is neon, then 3s2, 3p6, 3d10. This configuration you will do, or already a lot of students know, this is in periodic table you will do, or in the atomic structure also these examples are given up to zinc example generally. So by that way I am assuming that these things you know, then only we can use it. So here valence shell, how many electrons? 18, third shell. And this is termed as which configuration? Pseudo inert gas configuration. So now apply the which point? Fifth point, that cation with pseudo inert gas configuration has more polarizing power than inert gas configuration. Why? Because of the poor shielding of 10d electrons. If you know about that one, if you know about poor shielding effect from periodic, you will do little bit idea. If you have, you can easily understand. Due to poor shielding, Z effective increases, and when Z effective increases, polarizing power also increases. Hence, finally, the key point you can use, polarizing power of pseudo inert gas configuration is more than inert gas cation. Therefore, NaCl and CuCl, out of these two, which has more covalent character? CuCl has more covalent character because it has which configuration? Pseudo inert gas configuration. Better not to apply here. Why? Because size factors are not much variable in case of Na plus and Cu plus. So this is specific example where one is inert gas configuration and other is pseudo inert gas configuration. ठीक? So that is the part from the Fajan's rule and its factors. When you get the modules, you can solve other type of examples, but in NCERT, beyond it not given. Completed? So that I can show the points which are mentioned in NCERT, quickly write it down, then we can go through the page number 112. On page number 112, you will read this portion. You will read that portion given here. Then you will read this part, which is given. Smaller the size of cation. When you will read it, before that you have completed the notes, so that when you read it, you will just revise these points. First point completed, second completed, in third you can underline also later on. Electronic configuration n-1 dn, typical of transition elements. They have more polarizing power as compared to inert gas configuration. Okay? Then you will read this portion where which terms are used. Polarizing power is used for cation and polarizability of anion is used. ठीक? So this is the page number 112, or as per your old NCERT, it is maybe another page number. Mention the page number for your convenience in your notebook also. Up to this part completed. So we have done which part? Last class, ionic bond, definition, lattice enthalpy, and Fajan's rule today. This portion is completed. Can I change the pages? We go backward towards the covalent bond. Can I change? ठीक है. Now go back to the initial page number 105, I think it is. So you will read this portion after the class, which is on page number 102. Here on this, in this NCRT, it is 102. देखो, which portion you will read now? We will start covalent bond. Covalent bond means what? The bond is formed by the mutual sharing of the electrons between participating atoms. ठीक है? Then here you will read the story given about Cl2 molecule. After that, you will underline right now octet rule from here. This can be useful for statement type also. You can underline this portion. From here you can underline octet rule यहाँ से लेके this part. Done. ठीक है. अब these examples, still read it, but no need to add any theoretical point from here. These are basic terms, no questions are asked from that, because already in this chapter we have important models, VBT, VSCPR, hybridization, MOT. Questions are framed from that, but still you will not leave reading of any line. That's the purpose. So you will still read covalent bond, octet rule, and slightly relevant part is the limitations. Dot structures, Lewis dot structures, we will write later on when we complete the models, because it is not that important. So now this portion still you will read. Remember, this page you will read 102, story you will read still, dot structure, and then you will read up to which part? Here Lewis structure. If you possible, you can read that portion, dot structure. Formal charge separately we will do. And then important for us is now limitations of the octet rule. ठीक है? This part is relevant for us. So in the notes you can do what? You can mention in the notes as it is right now. These terms you will go through after the class. Which term? Covalent bond. ठीक है? Definition all know, the bonds which are formed by the mutual sharing of the electrons between participating atoms. This is termed as covalent bond. Other term is what? Other term is Lewis octet rule. So covalent bond, you can, if you want to write, you can write, otherwise you can write after the class. Bonds which are formed by the mutual sharing of electrons between participating atoms. ठीक. Then you write directly the octet rule, Lewis octet rule. Or you can copy it. I think better it is given there, nothing new. What is the meaning of octet rule? Understand what is the meaning of octet rule? When bonds are formed, then every atom tries to achieve the octet either by sharing of electrons or by transfer of electrons. That is the basis of octet rule, that every atom tries to achieve octet by sharing or by transferring. For hydrogen, it is duplet. Hydrogen will form what? It can maximum accommodate 2 electrons to achieve which configuration? Helium configuration. Getting it? So this portion better to write from the NCERT underlined which I have given. Okay, that portion when you add, it is similar. Nothing I have said new. Our focus will be on the limitations right now. Okay, but you will not skip your notes whenever you come in the online offline mode. Whenever you come back, because a lot of students are in online, but they'll surely be coming in the offline also. Most of you will come back. So that time, whenever you I meet you, maybe I'll check the notes also. I'll see that randomly you have written or not. ठीक है, octet rule you can write from the underlined portion. Now directly go to the limitations of octet rule. We are not discussing in between part. That's why I'm saying keep on underlining which portion we are doing. With time it will be covered. Limitations of this rule. ठीक है. First limitation, what is given? Which type of compounds are existing which are electron deficient compounds, which are named as hypovalent compounds. Hypovalent compounds exist. Hypovalent compounds exist. As per octet rule, they should not exist. Why? Because the central atom has less than 8 electrons. So the compounds where central atom has less than 8 electrons. These are which compounds? Hypovalent compounds, and they compound also exist. So they are lying in which category? Which are drawbacks or limitations of octet rule. For example, what is given in NCERT? LiCl given, BeH2 given, BCl3, BF3, AlCl3, AlBr3. These are examples of hypovalent compound. AlF3 is not there. AlF3 is not covalent, it is ionic. So that will not lie here. So that is extra information not requiring with the octet rule. These are the examples where the central atom has less than 8 electrons, and such compounds are termed as hypovalent compounds. ठीक है भाई? Next is which type of compounds also exist where central atom has more than 8 electrons, and they are termed as which compounds? Hypervalent compounds or expanded octet compounds. So that you can mention here, hypervalent or expanded octet compounds. Other names you will get, you can add in the notes, which is other name is superoctet compounds also. So second category is hypervalent. Hyper generally you understand. Hyper nahi hota, we say this person gets hyper generally. Like this, hyper. So other will be hypo, which is less than 8. Hyper means more than 8. So here you can mention central atom. More than how many electrons? 8 electrons. Which example most commonly? You can add more examples. In the NCERT given, in the module, you can add, it's up to you. Which example most commonly we take? IF7. Or we can say H2SO4 example clearly given on this page. Or SF6, PF5, PCl5. Or it is SO3, etc. So in these compounds, if you observe, central atom has more than 4 bonds, and more than 4 bonds. Each bond has how many electrons? 2. So more than 4 bonds means definitely they have more than 8 electrons. आई बात समझ में? Therefore, in all the cases, they are in which category? Hypervalent or superoctet compounds. Other category is odd electron molecules also exist. Odd electron molecules also exist. But as per the Lewis, they should not exist octet rule because they should combine to become 8. But there are also some molecules where they have odd electrons. Which example given specifically? NO, NO2, Cl, O2, etc. These are the examples which are given in the odd electron molecules in NCERT. I think two are only mentioned here. You can add one more example, which is ClO2 also. Yes. These are all which molecules? Odd electron molecules. When you do the summation of the electrons, you will never get an even number. NO 8 plus 7, 15. Same way NO2, it will be 16 here, it will be 7. So you summation you will not get. So these are some examples which are limitation, and which limitation, which example? Odd electron molecules. Other points are also given there. Like by this Lewis octet rule, we cannot explain the shape of the molecule. We cannot explain the stability of molecules. So that point you can mention here. Mention that point. Fourth point, unable to explain shape or stability of molecules. Unable to explain shape or stability of molecules. Next point, unable to explain why O2 is paramagnetic. Unable to explain why O2, oxygen, O2 is paramagnetic. Take sixth point is the basis of this rule. The basis of this rule which was inertness of noble gases. The basis of this rule, which was inertness of noble gases, became invalid because some inert gases also form compounds. Because some inert gases also form compounds. Some inert gases also form compounds, like which example? XeF2, XeO3, XeO2F4, krypton, KrF2, sorry, etc. So this point is what? That the basis of the inert gas, the basis of the octet rule was what? That atoms try to achieve the noble gas configuration. Why? Because it is considered that noble gases do not react and they are highly stable. As per that, this rule was framed. But later on, as the time goes, it was experimentally observed that some of the noble gases also react. And if they are also reacting, the basis of this rule, which was based on the inertness of the noble gases, somewhat becomes invalid. Because foundation was that noble gases are inert, but later on found they are not inert, they are also participating in some compound formation. For example, these compounds. ठीक है? Getting it? Written? This point written? ठीक? So that is the part of the Lewis octet rule, in which you will again read the NCERT part, its limitation, add more points, but that is the only part. Dot structures will be covered in the coming lectures, not in next lecture. Less important, we will do later on. ठीक है, page numbers mentioned, those page numbers you will read. In next class we will meet. Take good care of yourself. Keep on working in the NCERT notes. When you will get the assignment, you will solve the extra questions. Okay, Rakesh. Prasad ji will send. It will be informed to the students before the exam. The syllabus will be shared in the groups itself. ठीक है, okay, चलो, take care, bye bye.